All right, here are the solutions to a differential equation question in 2023. A bottle of milk is taken out of the refrigerator and placed in a pan of hot water. The increasing function, models the temperature of milk at time t, where m at t is in degrees and t is in minutes. M satisfies the differential equation, so the derivative of m is here, makes it a differential equation. And it says at time 0, the temperature is 5. So we have a point 0, 5, which is also explained here, 0, 5. All right, a slope field is here for this differential equation. Can you draw a sketch, a solution, using the point 0, 5? So right here is 0, 5, and we're just going to follow the slopes and how they curve and draw our picture. That's it. Beautiful. Part B. Can you do a tangent line to approximate this for the temperature of the milk? So I'm going to do that on a separate piece of paper. So for a tangent line, now in this case we have t and m. So we normally start with x, y, and the slope. Let's see if I can show that in. But I'm going to use the letters that are in the question. So instead of x, it's t. Instead of y, it's m. And then this is just the slope. I'll write it just like that so you don't mix up the m's. You are given a point, 0, 5. So t or x is that, and that is that. And we need to find the slope using the derivative. So it's given that the derivative is 1/4 40 minus m. So in this case, to find the slope, the letter we actually need is not t, but m. So I'm going to plug in 5 for m and solve it. So we have 1/4, 40 take away 5, and I'm going to solve that. So 40 take away 5 divided by 4. I'm just going to leave it just like that. So the equation then would be, and we can use x's and y's if you like. We start with the slope. I'm going to use t. So it's t minus 0 and then plus 5. You could also just write this. And it's the same. 35 over 4, t plus 5. Both are the same. Then it says, use this tangent line to approximate it when at time 2. So m at 2, what that would mean, approximately using the tangent line, is we would use 35 over 4 times 2 plus 5. So you plug in at 2 minutes, plug it into the line, and then get your answer. So that's 75 over 4 plus 5. That's fine, and leave it at that. That would be in degrees Celsius. And you can leave the answer just like that. Part C. In part C, it says write an expression for the second derivative in terms of m and determine whether the approximation is under or overestimate. So first of all, the second derivative. So we're going to write down what we're doing. And then to find the second derivative, we take the derivative of this. So to make this simple, I'm going to distribute. So 1/4 times 40 is 40 divided by 4, which is 10. And then 1/4 times negative n, we're distributing as this. So when I take the derivative of 10 is 0. The derivative of negative 14m the derivative is just negative 14. Sorry, negative 14, negative 1/4. And I want you to notice there's no variable attached to it. That means the second derivative is always negative. That means it's always concave down. So if I have a tangent line touching something that is concave down, I want you to notice this tangent line is above concave down. If it was concave up with a tangent line, notice how it's under. It would be an underestimate. But this is an overestimate. So we're going to write that down. So we're going to write down it is an underestimate. Sorry, concave down. It is an overestimate since the second derivative is less than 0 or concave down. Done. Part D. Can you separate the variables? So can you solve the FRQ? So let's do this one together. I think that the FRQ questions can get you a lot of points if you're good at these FRQs that we practiced a lot in class. So we're going to separate the variables. So I'm going to divide by 40 minus m, and I'm going to multiply by dt. There's my first step. So now they're separated. I'm going to integrate this. This is a logarithm. If I take the derivative of the bottom, it matches the top, but it's -1, so I need a negative in front, so it's going to be negative, then ln 40 minus m. Don't forget the absolute value bars. 1/4, if you integrate it's just 1/4 t, and then plus c. We're then going to plug in the point, which is 0, 5. So for m, we're going to plug in 5. And then for t, we're going to plug in 0, and we're going to solve it. So 1/4 times 0 plus c over here is negative ln. Now the absolute value of 35, I don't need the absolute value bars anymore. It's just negative ln 35. I'm going to continue up here. So we have negative ln 40 minus m equals 1/4 t minus ln 35. Now I need to solve for m. By the way, you would get a point for separating the variables. You get 2 points for integrating correctly, a point for finding c, and then the last point is this. So if you're having a hard time with this, it's 1 point only that's left. All right, to solve this, I'm going to multiply everything by -1, or divide. Next, I'm going to write, to solve a logarithm, you write it as an exponential. So what's inside the logarithm is 40 minus m. And then it's e to this exponent. You don't have to simplify it. Now, when I remove the bars, it could be plus or minus, but we know it's positive because the y-coordinate is positive. Now, at this step, what I do is I add m and I subtract the e, and then I'm done. You could make this look prettier, but you don't need to. Done. So again, at this step, I added m and subtract the e. M is by itself, and you separate the variables. You integrate it and solve for m. Beautiful. Done. All right, let's look at the next question for your homework. And that was done in less than 8 minutes. So first, I want you to press pause, and I want you to try it first. Oh, I printed out the wrong one. All right. So I want you to look at it. I'm just going to look at it. I solved this to begin with. I was going to print it out separately, but I forgot. So the next question we're doing is this one. We have a differential equation. It kind of looks ugly, but it's going to be okay. Given a point, and then it says, hey, can you draw the solution through 1, 2? So find where 1, 2 is, and then follow the curve. If it's horizontal, it's a turning point. Follow, turn, follow. Here, turn, turn, follow, turn, follow. It looks like a trig. It is a sine or cosine, right? It looks like what it is there. It's actually a cosine. Once you integrate it, it's fine. All right. Next step. Write an equation for the line tangent. Notice we're doing that question again. So let's do this. I'm going to do it on a separate piece of paper. For this one, we do have x and y, so it's traditional, x, y, and the slope. So you're given the point, 1, 2. To find the slope, you use the slope or derivative, and you plug in for x and y, and then solve it. So this is going to be 1/2 sine pi over 2 times 1, x is 1, square root of 2 plus 7. So y is 2, and then we're going to solve this. So sine of pi over 2 times 1 is pi over 2. The square root of 9 is 3, and so if I put this together, and if I need to, at pi over 2, that's up here, the top of the unit circle, the y-coordinate, sine goes with the y-coordinate, it's 1. So this answer is 3 over 2. Now, when I put this together, the slope is 3 over 2, x minus 1, and then plus 2. There is the tangent line, and then you need to approximate 0.8. So then plug in 0.8. You actually don't need to simplify it, so just leave it, and you don't have to do anything else with it. Part C. In part C, it says it's known the second derivative is positive. Is the approximation an overestimate or an underestimate? So we did this just like the year before. Is it an under or overestimate? So if it's greater than 0, that means it is concave up. Draw yourself a picture. So if it's concave up and you draw a line touching that, is that line below or above the graph you just drew? So that line is below. That means it is an underestimate, since the second derivative is greater than 0 or concave up. D. See how I think like this kind of question, a differential equation, gives you a lot of opportunities to get points. So here we're going to again separate the variables. And we're going to solve it. All right, so we're not going to be intimidated by this. So we're going to first separate the variables. So I'm going to divide by the square root of y plus 2, and I'm going to multiply by dx. There's step 1. If we can separate the variables, you get a point. Now I'm going to write it friendly. So this is y plus 2 to the exponent negative a half. And then, hey, I'm just doing a video right now. That's okay. Yeah, like 5 minutes or so, or here, let me. All right, let's finish this. So we're going to integrate this, which means we're going to add 1 to the exponent and divide. We're going to integrate this by the hook should be pi over 2. It was a half, so you divide it. So it's 1/2 divided by pi over 2 together. 1/2 divided by pi over 2. So if we put that together, that's 1 over pi, because the 2's cross out. Oh, it's blue. The 2's cross out. That's pi over 2. So the 2's cross out. So it's just 1 over pi in front. And then we can integrate this. So this is just going to be 2. This we're going to have 1 over pi. This goes away. Sine is negative cosine. Plus c. We're going to plug in 1, 2. So if I plug in 2, and if I plug in 1, that's just pi over 2. And then solve it. This is the square root of 4, which is 2 times 2, which is 4. The cosine at pi over 2 is 0, so that's what c equals. It's just 4. And then I'm going to put it all together. So I'm going to write it here. So all together would be 2y plus 2 to the 1/2, 1 over pi, cosine pi over 2, x plus 4. To get y by itself, I'm going to divide by 2. So if I divide by 2, that's what it would look like. And then 4 divided by 2, square, not square root. So to undo that, I'm going to square it. And then subtract 2. Done! All right, Mr. G Math over and out. Until next time, proud of you.